Okay, hi guys. Today we will be doing one of the final parts, which is the polymerization. As you can see here, for A2, we mainly talk about condensation, polymerization. You can see here. Okay, right? But the questions always come out together with addition polymerization. Now remember, for addition, okay, addition polymerization, it happens only when the monomers, okay, monomers have a carbon double bond carbon as a starting point. So it's alkenes, okay? After we can see the differences, how do you identify whether polymerization is addition or whether it is condensation. Okay, before that, I will go through this addition polymerization with you as we go along. But here you can see that they want you to focus on, for A2, condensation polymerization. Okay, now, right? So describe the formation of polyesters and polymers. Now in Form 5, you actually done this before. In IGCSE, they actually you actually done this and they've asked questions on this before. 1, polyester. 2, polyamides. Why are they called polyesters and polyamides? Basically because the functional group or the linkage is an ester, right? So what is a linkage for the ester? Form 5, if you recall, it has got this functional group here. Okay, the carbonyl group O, and then here this is called what? The ester linkage, if you recall. Okay, linkage. What makes it a polyamide? Well, again, in the polymer you will have amide linkage. This is your amide which you just finished. Okay, this one here. This is called your amide linkage. Okay, so you can see that this will join many of the monomers together. Again, they ask you what are monomers. Now you take the definition from here. See, small molecules. This is actually in the IGCSE, they use the same word here. What are monomers? They are small molecules. Okay, monomers are small molecules that join together to form a polymer. That is the definition, by the way. It's a simple thing, so you need to know, okay? Monomers are small molecules joined together, right, to form a polymer, okay? Now, if you see down here, what is this nonsense? Okay, now if you see down here, I've got here, all right? Okay, the terms, definitions, okay? So what are monomers? Small molecules joined together to form polymers, okay? So the key word here is, of course, small molecules, okay? And of course, joined together to form polymers, the two keywords for monomers. Polymers. Polymers are long chain molecules, okay? Joined by or made by covalently bonds joining many small molecules. So what small molecules and monomers are synonymous, so to say. Okay, now let's go back to the syllabus. Okay. Okay, now here we have, you have to know, actually it's revision for Form 5 idea. You have to know this thing here, describe how they form. Okay, describe the characteristics, okay, of condensation polymerization. That means, well, when they are formed, what are the ingredients, what are the reagents, and what are the products, right? So we have to look at pterylene, right, which is the example for polyester. For polyamides, polyamides is very open here. So polyamides can mean basically two types that you want to say, okay? Polyamides. it can mean one here, the natural one, which is the this is protein. Okay, which is polypeptides. This is the natural polymer. Then you have the synthetic one. Synthetic, DIC, which is your nylon. So here, how many types of nylon are asked? See, proteins, these are your natural polyamides, okay, which is your proteins when you eat, Nylon 6, there are 3 given here. 1, nylon 6, 2, nylon 6. I'll show you the difference of those, okay? And Kevlar, Kevlar, of course, is to make your bulletproof vest, okay? So 3, as compared to polyester, we have only 1 here, which is Tellurine, Tellurine is used to make your trousers and your shirts, okay? They are the John Travolta type, they are non-crease. You can wash and wear kind of stuff. All right. You also need to see in part 3, deduce a repeat unit. The key word is repeat unit. So there are a few important words in polymerization. One, of course, is the terms, monomers, polymers. The terms, condensation and addition. The terms, polyester, polyamides. The terms, linkages. The terms, repeat unit. You need to know what's a repeat unit. Okay, so deduce a repeat unit of a condensation polymer. Not only of a condensation polymer, but also a repeat unit for an additional polymer. So they will ask you. So we're going to lump all together. You have done this before in Form 5, okay, also on your AS. Okay, so we will sort of revise them all together. Okay, obtained from a given monomer or a pair of monomers. Now, let me see here. One kind of monomer, this one, is called homopolymer. Homo means one, right? Hetero means 2, or poly, or they call it co-polymerization. Homopolymer means 1. Homopolymer. Okay, here a pair, that means a different monomers come together. Okay, they can call it co-polymers, or heteropolymerization. Okay, they can be 3 or 4. No, you can play around with how many you can combine as long as they can form the linkages. All right, last one here, identify the monomer present. You can see how the question comes out. They give a polymer, what are the monomers? Okay, give us a section of the condensation polymer. Okay, now of course here 21.2 also comes with it. The whole thing here, you can teach the whole thing one shot, otherwise you leave out loopholes. So I'm going to teach a lot. I'll come to the questions much later. Okay, predict the type of polymerization for a given. To predict type. The type here means what? Whether it's addition or what? Or condensation. Okay, for a given monomer, one monomer or a pair of monomers. Deduce the type of polymerization reaction which produce given section. Okay, same thing. Okay, type of polymerization. All right. So they either start with monomers or they start with the polymer. The difference is here they give you the monomer, here they give you the polymer. Okay. The properties they actually will also ask you together. Okay, I just want to talk about a few. I may just bring out the idea that here the properties you can see whether they are density, hard or soft. Okay, kind of thing, and whether it is hydrophilic, hydrophobic, like your contact lenses, right? Soft lenses or hard lenses, kind of stuff. Okay. 1:45. Now I want to check the time, and of course here the side chains because cross linking afterwards. Okay, we will talk about cross linking, right? cross-linking. Hopefully, time we do it. Cross-linking to make the polymer harder. You've done in Form 5. Those who've done in SPM will find out the Malaysian syllabus. That vulcanized rubber is cross-linked. You know, the polymer, we use sulfur to cross-link, make it harder. So your ties are all cross-linked by sulfur. Okay, so now let's start. All right, so we got the whole thing going here. Let's start. All right. Now here you can see I've gone through the types of polymerization, addition, and condensation. All right. Now, basically, what makes the substance undergo addition polymerization? Very simple. I told you here, if it's addition here, the monomers must have carbon double bond carbon. And these two carbons here will be in the main carbon chain or the skeleton raw chain. I should have to okay. So this one must be there. Now let's look at an example here. Okay. So here we have got another P unit. Now I take an example here. Addition. Okay. So you have got this polyethene. Okay, or polyethene for short form now. Okay. The word ethene here, polyethene. Ethene means you start the monomer with ethene. Got two carbons here. This is the simplest of all, right? So if I were to draw here, now I think I draw here so that you can have more space. Okay. Now this is the raw one. Okay, the raw substance H here, H here. I'm going to draw three. Okay, three here, three monomers. All right. I hope I got space enough. You can see, right? Okay, three monomers here. Okay, now how do you start the reaction? Actually, what they care was an initiator, a starting point. An initiator normally is a free radical. It's a peroxide, normally they say. So a peroxide, when the peroxide breaks, they form a free radical. This is the lone electron. Okay, it's a lone electron, or free radical. Okay. Okay, remember now, free radical substitution. So what happens is that when they do it this further here, now remember the arrow, half arrow, just jump to here. So half an arrow. So the other one will come to here and join to this guy here. And this one will join to here and will continue the whole process like a chain reaction and go on here. So you will get like this, your X here, join to your carbon, and your carbon, and this is the first monomer here. The H, nothing comes out. Okay, this one is called addition. Something goes in, nothing comes out. I always used to say in the normal way. Okay, H here. Right, now to the second. So nothing is, well, the only thing added is each other, but nothing comes out. There's no elimination of substances, unlike your condensation, which is normally water, or HCl, whatever. Okay, you can. Okay, now I'm going to draw like that here. Now I'm drawing here. They ask you sometimes for, okay, I'm going to draw a line here and I put a box here. This should be the way. So remember, so there are three. 1, 2, and 3. So there's a polymer. This is how you draw a polymer with 3 repeat units. Okay, now the repeat units are, of course, it says, so repeat is CH2, CH2. So can I put this as a repeat unit? Cannot. Salah, wrong. A repeat unit must show the minimum molecular formula of the monomer. So what's a monomer? The monomer is CH2CH2. That means the repeat unit is this one here. See? Okay? Which means you must show like that. The best, of course, is to write the line here. Now this is called the tail. No? In the marking schema, you must put the tail. The tail represents, that means it's continuous. Okay? I can put CH2 like that, CH2 like that. Can. This is called a repeat unit. You must be careful what you write. Repeat unit. Okay? Or you want to be, extra careful. Draw all the one like a display formula. Can, no problem with that. Okay, also can. Remember, it must represent at least the minimum molecular formula of the monomer, right? This one tak boleh, cannot. Okay. Now, another thing to notice, of course, is that for some reason here, polymethylmethacrylate or perspec. I'm sorry, I don't know how this computer. It's like, here should be connected like here. Okay, here. Okay. Okay. Now, so now in exams is so now well. Let me just show you. So teaching on the board is so easier. Okay, now I'm going to go here again. Okay, now I'm going to draw the see this is what they give you is at least CH2. Okay, sometimes they don't even give you the double bond, so you have to be careful. Okay, now this is the monomer. Okay, it's a monomer. So how do you start to draw? If I ask you to draw a polymer with 3 repeat units, focus. Remember, focus on the carbon double bond carbon. The rest of them don't care. Put up and down. So now, what is the carbon double bond carbon now? Okay, I'm going to give another color. Blue, my favorite color. So now these two, where the double bonds are, you don't care about all the other atoms. You don't care. So you put the C double bond. You write that first. Okay, now, right? So that is the main concern. Okay, now I want to put red color here and fulfill the rest. Okay, that means now here this one got 2H. Follow carefully, follow. Now this is form 5, okay? I teach you in form 5, I tell you first, oh, don't know where you come from, I tell you. CH3. Put everything up and top. Don't block anything here. Don't block anything here. Don't here, this part here, and this part here, don't block. Okay, now, don't block here. So all on top here and on top here. Okay, now done, draw the bottom here now. What is this? CO2CH3 now. See now? Why is it don't block here now? Because I will rub it off. Okay. I don't know why it didn't come up. Okay. All right. Now, so I now draw the other one. Okay. Okay. Now this one monomer, I draw the other one. I focus on the main thing. The main thing is to keep the main thing the main thing. Okay. So here we have the other thing here, H, right? And H here, correct? And of course, it's the same one. This homopolymerization, homopolymer. That means one type of monomer you can form the thing really, like polyethylene, polysperspec, same thing. CO, leave all the side chains here. All right? I draw the others first. Okay, I'm going to change color. H3. This is H. This is CO2CH3. Okay, now I'm going to put a blue color. Okay, so here is my main fellow here. Okay, so what happens? I told you here with the X. I don't care what is it. There's an electron area. So they will start to polymerize. Okay, right? Okay, you can draw this. Don't draw this. Okay, now, but I'm just showing you this. What happens? Okay, and it will go on and on forever until the flow comes to a close. So what you get, of course, is this one here. I'm going to draw up there, no space down here. Okay, what happens, of course, from here, right? You from here, okay? I'm going to draw. So now I'm going to draw a line. It's a tail, a bracket here to show me that it's continuing. It's called a tail, no? I don't know why they call it a tail, but don't care. It's not a problem. C. Bond C. See now, the single bond here is still there, isn't it? Okay, this one has this bond is broken now. So now this is the one here, and then here will be your okay. I just draw the every 2 C's. Every 2 carbon came from the monomer. Okay, log. I'm going to change to red so that you can see where it came from. Right? So here, of course, the H and H, see now? Okay? See, when you draw, when you revise, you draw out. If you not sure, then use different color and prove to yourself. Now these are all the side change. You don't care. Just leave it there. Don't go and interfere. Put inside in a side here. No, don't. This is your H. H. Say, sir, can I put the CH3 here? Can. Right? CO2 say can. But because you don't put it because there's a big group here. Right? This big group here, they call it steric hindrance. So they very low probability. Okay? So here is your CH3. And this is CO2 CH3. So H here, CH3 here, and your CO2 CH3 here. So remember now, these 2 carbons came from where? Came from the original monomer where the double bond is not. See now? See? So you must understand. See? Every 2 carbons will form your monomer. Yes? Very important after I show you why. Okay? So now this, of course, is the what? It's a polymer with what? 3 repeat units. They will ask you what? Is it clear? Okay. So put all the side chains on the top and the bottom here. Don't go and put them on the side here and will disturb your whole train of drawing. Can? Okay, now you can see here, PVC, I won't go through all this, okay? You can go and try it yourself. Now basically all these things, all these addition polymerization, they are very, all of them, okay? Polystyrene is the worst one. PVC, I say polyvinyl chloride, now this is AS, I'm telling you, okay? I'm just repeating. Okay, PVC and polyvinyl chloride, now this is used a lot in pipes, water pipes, you know? Toys. Barbie toy, can toys, whatever. Okay, shoes, the cheaper version of the leather, see? Right? They are non-biodegradable. Why? Right? And they burn, get toxic fumes because there's chlorine here, see? So get toxic for HCl. So they are quite bad for an environment. Right? Non-biodegradable, cannot break. Why? Because why? See, there's, of course, they say that the reason is because the carbon bond is very strong. Okay. Similarly, the carbon hydrogen bonds are very strong, right? Only can be destroyed by burning. But basically, like why condensation polymers are more biodegradable? Because they can undergo hydrolysis. You see, some cannot. The answer is because they cannot undergo. Because cannot. Okay, remember, sir, cannot undergo. Undergo hydrolysis. Why hydrolysis? Because in nature, there's water, water vapor from the rain. So water can be a reagent to break the ester linkage. See that? Okay? To break this one here. Hydrolysis, man. And to break the amide linkage also can. Hydrolysis there. Yeah? So for your polyester, which is this one here, just to let you go a bit, okay, I know I jump here and there, but hey, and your polyamide, your nylon, right? They both can undergo hydrolysis. That's why they are more easy to break down than your addition polymerization. There's a question here, no, actually. So hope I can go this far as well. Not this one. This one. Now I think this one. No, this one. Never mind. Okay. Probably this one. Yes. See, says in the question they say. Later we'll look at the question. Okay. In the question they say why polyethylene is not biodegradable. 2 marks, no? Okay? The first mark is polyethylene is non-polar. Its bonds are non-polar. Therefore, not easily undergo hydrolysis, not easily hydrolyzed. So if they ask you why polyester and polyamides, they both are biodegradable. I try to have a good what kind of writing, okay? I see all my writing is very bad. Biodegradable. Why? Because they contain, right? In polyester, they contain what? The ester linkage. This one mark. Okay? Linkage. And for polyamides, they contain what? The amide linkage. So you must tell them what they contain. Okay? Linkage. So what? Therefore, they can undergo what? They can undergo what? Hydrolysis. 2 marks, no, guys. See not? You must see what they contain. Okay? Right? These are, of course, I think they should give more marks because there are 2 types. Right? And because of this, because they can be hydrolyzed, they can undergo what? Hydrolysis. Why? Because in nature, in your normal everyday, there's rain, isn't it? There's water, and there's heat, is it not? So obviously, this will help the whole thing to be biodegradable. Okay? So now I'm going to go back here. Right? So I'm still on addition polymerization. Okay? Now polystyrene is the famous one. I show you a question. Okay? Questions here to to explain all what I want to do, but no time. Okay, 247. Maybe got time. Maybe I'll do a bit more video. You fellas don't know whether you see my videos or not. I tell you, you lazy fools. I tell you. Never mind. I do my job. You don't do your job. That's your funeral. You want to bury yourself. You can go ahead. I mean, I cannot stop you. But you want to do well. You view the views a few times. Okay, now here. Question 4. Ethyl benzene is a popular starting material and so forth, Okay, in the making of polystyrene or polyphenol ethene. Why is it called polyphenol ethene? Very simple. Phenol means there are 6 carbons. Okay, so there's 1 flap here, so CH5. Means one of the hydrogen here has been what? Substituted, and of course your ethene here to a C. Ethene means what? Double bond. C not H here. Now this is your monomer. It's true, isn't it? This is your C6 H1, C6 H5, isn't it? Right? Because hydrogen here has been kicked off. Okay, so this is a polyethene, right? And from this you make styrene. These are your styrofoam. You're packing for a TV, the white color stuff. And you buy a new TV, a new handphone. They come in a nice package. Okay. To so that you won't shockproof. Okay, the chairs actually the one is quite expanded because the air bubbles blow it up, so all the small bubbles there. All right, and of course the chairs, the hard chairs, they're just called polystyrene because there's no air bubbles there, so it's very hard. Okay, now here you can see down here they ask you. Draw the structure of the repeat unit of polystyrene. Famous question there. Okay, nothing famous, nothing difficult about this. Okay, draw the structure of the repeat unit. Only a repeat unit. Now, of course, if you find it difficult, if you didn't practice whatever, then you can do the whole process of polymerization. But you don't have to. Okay, you know that. Okay, let me draw the whole thing for you, for those of you who are gurus. Okay, now I said focus, I say, on top here I told you, right? Focus on the double bond. See here. I got this whole damn thing here, this whole thing here, you don't, like here, very good. Now, see, they draw the ring under here now. If you draw the ring here, that means you're going to put here and you block the other C, so you block it here. So put this one down here. See now? Okay. So actually now I'm going to draw it down to a space. Okay. So if you are smart, I know you are, but you're damn lazy. Here. Okay. Draw first the double bond. Then draw all the things up and down. Okay. See, my writing has improved after 10 to 11 videos. I think I better improve, otherwise I'll be an idiot like you. Okay, edge here. Okay, now, perfect. See, nothing to hinder here and here. So I put another one here. So I'm drawing the whole stuff here. Okay. So I'm teaching how to draw. I think sometimes all of you will just draw everywhere and then you block the entry. See. So up and down. One more lah. Okay. All right. You can see there. Okay, of course, I told you if there's a initiator here, blah, blah, and so forth. It's good that you can do this process so that you know what's happening. Now, this is actually called free radical addition. You know, in alkanes, go about free radical substitution. This is called free radical addition. You learn this in university, like you ever get there, lah. Some of you will not. From what? Dash. See the tail. The blockade to show that it's repeating continuous. Now I'm going to draw 3. Remember, no more double bonds there. But this will remain here. No reaction is addition polymerization. See, H here, H here. Now to the next fella here, H here. Yes, now I'm drawing now a polymer with what? 3 repeat units here now. Here, H. I was very stupid. Okay, the fan makes noise. I hope it didn't bother you just now. Okay. Sometimes I'm quite stupid. I forgot what to do. Getting old. H. Join. C. H. And the ring here. And the C here. And the H. Okay, now this. Draw the tail. Okay. I can put an N here, but doesn't really matter. So now this is the polymer with 3 repeat units. But if they ask you for a repeat unit, I don't draw this one. Just draw like that line. See how to draw a repeat unit? Very simple. Every 2 carbon per line. Every 2 carbon per line. Now. See now. Because every 2 carbon it must come from the monomers. Now. Every 2 carbon. Don't care. 1, 2. You can start from here. 1, 2. Draw a line. 1, 2, draw a line. Okay, I can say 1, 2, draw a line. Okay, now can start from here to here, or here to here. Doesn't matter, isn't it? Right? It's the same. Just reverse it only one. So okay, so what it means that now just draw like that. Yeah. Okay. Yeah. And you can put C6H5 up to you lah. Okay. That's it. Can? Okay, or you can put like that lah. Yeah, if you want me to, you can put CHH first. Jangan susah hati, it's okay. And C6H5. And yeah, either way is correct. Can? It doesn't really matter. Now, look at the next one here. Okay, now this is a bit different. There are several polymers that consist of phenyl, ethene, co-polymer or hetero. Like co-education, co-polymer or co-polymers. It means like 2 monomers with the other monomers. The following formula shows part of the chain of the co-polymer. Okay, they will come out. It's not stated in syllabus, but they come out because it's common sense. So now look at this first. The question we ask is now: Is this polymer? Right? Addition polymer is addition polymerization, or is it a condensation? Okay, very simple. See, I'm going to take you into another question, okay, which I think I don't know whether I should. I'll do it. Okay, I'll do it now. Now let me take you to the other one now. The other question I show you here, which is in page 259. I use it for my Form 5, you know, because I said they should know how to do it because it's common sense. Okay, 259. I give a A2 question for my Form 5. They can do it. They're quite smart, you know. The fools are lazy in it. 259. Okay, up here. Beautiful question. Cambridge has got beautiful. Okay. All right. Okay, this will summarize the whole idea. Each of the following structures is an 8-atom segment of the commercial polymer. Why 8 atom? 1, 2, 3, 4, 5, 6, 7, 8. That's why it's called 8-atom segment of a chain, of the chain of a commercial polymers. Okay, so you can see it's all 8. If you want to count, I'm going to count for you. Okay, you can count yourself. You know, here 1, but it's not important. 2, 3, 4, 5, 6, 7, and so forth. Okay, I'm going to rub it off. I just want to show you why they say that. Okay, no, print shit. No, I don't erase. Okay, erase. Okay, sometimes they must have one thing. Erase all. Alamak, I'll do again. No more strength. Erase. Okay, let's go back to here. Okay, I wish it was voice activated, man. Also, this is a spoil. Okay, let's see. Now, sorry. Okay. For each structure, decide whether it is part of a condensation, here, or addition, polymerization. And draw the structure of the formula of a monomer or monomers, which the polymer is made of. This is the famous question. 3 times came out like that already. Okay, so they give the polymer and ask you to, hey, what kind of polymerization is it? What kind of monomers are these? Very simple. Now, how do you know whether they are addition or condensation? Very simple. Remember, for condensation, right? For condensation, remember, right? They form only 2 types of polymers. What are they? Polyester. And what? Polyamides. Polyamides. Yeah. And polyester and polymers, of course, in the main chain, it will have the linkage of ester, isn't it? To a O, to a C, okay, to a O, see, right? Okay, so there would be, well, there should be something here, okay, to O. That means along the chain, you get C dash double bond here, and to and C, whatever, C here, and then the O, okay, another O here. Sorry, yes, O, the C, okay, another one is double one O here. What I'm saying is that along the chain, the main chain, the skeletal chain, the C will be interrupted by O. See now? Okay? Same thing with the amide. Interrupted by N, see now? H. And go blah, 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 blah. And then, of course, can be an N here, and then a H here, and then a C, and then one. So along the main skeletal chain, there will be a C and an N. C and an O. Unlike your addition polymerization, there are none. It's always carbon and carbon and carbon. Because why? Carbon and carbon, the double bond coming from the main chain, is it? You see that or not? Yes or no? Huh? I didn't hear you. Deaf and dumb, is it? Well, never mind. the main chain, the 8-atom chain. All right, here. C. This one, okay, to C. N. Not C. N here. This must be an amide, isn't it? Right, polyamide. To C. C. N. C. That means this must be condensation, must be a polyamide. Okay? What was that? So, that means it's polyamide, that means it must contain amide linkage, which is true. Circle for yourself. The amide linkage, you see it? Circle. Circle first. Every linkage, circle. Very important. Okay. Right? Now let's go down here first. So I can say that, oh, this is of course condensation. Okay? Now, second one. Okay, the main carbon chain. Here. Okay, the main chain, the skeletal chain, correct. So it's carbon, okay, carbon. Oh, it broke the carbons. Carbon. Oh, that means that it must be a polyester. Okay, so I now will circle now. Very important, I see now here. It is ester here, double here, and so here must be an O, you know. Draw it, don't care. Here is O, there must be C, and there must be double bond here. Now, draw it, don't care. They purposely make you like that so that to confuse you, right? If you know your stuff, you're not confused. Know your stuff. Of course, here we join to a C that you want to continue. Okay. Now then, circle again. Circle your linkages. This is polyesters, right? This is a polyester. This is a polyester. And of course, this is your condensation, polymerization. So now circle, okay, circle here. Do by yourself again so you can see what is actually happening. Circle here and circle here. Okay, remember here we'll continue now. Yeah, don't care, just circle here. Right? Now I'm going to stop here for a while. I'm showing you again. Now how do I fit in the find my formula of the monomers? Okay. I'm going to use a blue pen now. Okay, put it smaller bit. Okay, blue pen. Easier. See, now to do it, okay, very simple. Now this is my linkage. Yeah. My amide linkage. This also is my amide linkage, okay? 3 here. What I do is I will hydrolyze the part that will here. Here will break now. Yeah, remember? Okay, break here. Right? Here will break, isn't it? The N and the C will break here. Here's a break. So I will break every part that will break the C and the N bond, the C and N bond, okay? Same bond. So now I would remember if you want to put out here's an N, is it? Okay? Right, and there's a H here, and it's a good. You continue here now. Okay, so now I will circle. Remember, I will circle. Remember, now look here. I will put another color, so it's quite nice to put all these colors now. Okay, now to find the monomer, I will circle. That means from here, is where the monomer is not here, until the next breaking here. This here. I drag it up. Everything until here. This is one monomer. Again, beautiful, isn't it? Okay, now to draw it on here, I'm going to draw it over here, okay? So the N is N here. So draw N here. Okay, H is here. Now, of course, before they form the amide linkage, it must be H here, isn't it? It's not. Use your brains. You don't know, I'm going to kick your head. CH2. Right? include all these things here. Here. But remember, this is the whole thing, okay? To, of course, the CH2 here, right? And to here. And this is your diamine. Later you see that I know I didn't go to it, but never mind since we are in here. Okay? This is the first one. And then here. Now, next one. Remember here, the break, here. I put a different ink. Some of your even are blind, so I use it different. Okay, again, the break here, break here to the break here now. Now this is now. Okay, see now. So this is the other polymer. This is the copolymer. That means C double O. I got C double O. Of course, here to polymerize, normally you use a Cl or OH also can. Cl is better. I'll explain after. Okay, acyl chloride. Okay, but OH is the normal deal. They won't fail you. Here to another. Okay, double bond here, and of course a CHOH here or a Cl also can. See now. See? Easy now. Okay. Now here, let's go to here. Okay. Right now here. See this here? Now this is ester linkage, right? Ester linkage. This is ester linkage. Same thing as the linkage. There are 3 ester linkage here. Of course, because you extrapolate this part here. This is ester linkage. Of course, why? You extrapolate this part here. You have to, otherwise we have to see one. Okay now. So now you break again. Where do you break? In ester, you break it out. CO now. Here. Okay? I use okay here. Where you break? Here is it. Right? Where you break? Here is it. CO now. Okay? Not any other part. So how do you form the monomers? You have to do again. No, don't say, I know. You better do it again, I tell you. Where's the stupid? Okay. I don't know why it's on this. Okay, circle now. Here. I don't know why. Okay. Okay, here. Here, the whole thing here. The bottom. Oxygen here, this whole thing. This nice fella. This whole thing is the monomer. One of them. Okay, here. Okay. Again, see now. Okay, so here. So now this is oxygen, okay? So here is a carbon. So the first one, of course, is your carbon. Double bond here, O. Of course, this one will join to this is a carboxyl acid, okay? Or it can be acyl chloride, it can be Cl here as well, can. After I explain, okay? To CH. And here, the whole thing here, I can put the CH2, if I want to put that, okay, CH3 here. And then go up here, to CH2, and go down here to OH. See now? Right? So this is carboxyl acid and alcohol. Now the second one. Go down here. Go down here. Go here. To here. Again, this whole thing. This is the second monomer. Got it? Here. Break here then. Okay. So now what is the monomer? What's the monomer now? This one, this carbon here. So I put like that. C, I put out here, okay? C. Double bond here. Or no. So it must be an acid here group or an acyl chloride silicon. Go down to CH. Now you have to only one CH3 as compared to here got 2, isn't it? See? Different. They're different. Go up here, okay, to CH2, I put here H2. And of course to O must be alcohol, see now. So there are 2. Go back and process it. Okay? Now next one. Okay, the main chain. The main chain, carbon. They put the COH to confuse you. Carbon. I will not be confused, I know. Mr. Lai say cannot. So you better listen to me. Yeah, carbon. That means it must what? Addition, is it? That means now how do you pick up the monomers? I told you every two carbons in the carbon double bond carbon will participate. So 2. Okay, 2. 1, 2. This box here. 1 carbon, 2 carbon. Okay, this is one of them. Okay. So 1 carbon, 2 carbon, that means the whole thing here. One of them. So this one here. 1, 2 carbon. So there are 3 different things. But here is a repeat of who? Number 2, is it? This one here. See now. So how do you now write this one here? Okay, here. So remember, these 2 here must be double bond, yeah? So it'll be carbon, double bond carbon, a CH3 here, and a H, and a H here. This will be the first one, number 1. Number 2. This carbon, draw the double bond carbon first. Okay. The first one here join to what? CONH2. Put on top and bottom, don't care. Here with the H here. Number 2. And here, H and H. Is that. Number 3. These 2 carbon first. Okay. Carbon double bond carbon here. And the top here is to this big phenyl ring. Okay. Put C6H5, easier. Down is H, and here is H and H. So this is a co-polymerization, co-polymer or heteropolymer. 3. There are 3 here. Now, do you understand? Huh? Okay. Go back and try it. Do it again and again until you get the whole thing. It's all in the net here. You can do it. See again and again. Now, I'm going to go to a few more just like this. Okay. Right? Now, it shouldn't be so difficult. A levels, not D levels. Okay, let's look at the. Go ahead and try again. Now, there are similar kind of equation. Question 3, 4, 2. I've gone very slowly. I'll tell you. Okay. Now here. Right, 3, 4, 2. The physical properties of polymer depends on the average relative molecular mass of the polymer chains. And on the function groups of the monomers, the presence of such a blah, 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 created by itself. Okay, I was going to talk here. For each of the following polymers, give the structure of the monomers and the state of type of reaction used to produce the polymer. Okay, very simple and circular. This is a polymer A. Obviously, in this case, you can see, wow, now the main chain, nitrogen, carbon, nitrogen. There's an N here. That means it must be a what? Must be a polyamide, isn't it? Yeah? It's not. That means it must be must be condensation. So the what's the reaction here? Condensation. It's not. So now to draw the monomers, very simple. Now you can extrapolate here, put the C here and double bond over here. Yeah? Don't be like cannot do it. You're a bloody idiot. And here and a H here. Can continue, isn't it? Because that's what the chain is about. The tail is about. So now, if you do that, circle for me the what? Circle for me the functional group. Okay, the linkage here. Amide linkage 1, 2, and 3. Now break. I put a red pen. Okay. Okay, break where? Break at the link here. Break here. Break here. Break here. Break here. Okay, now circle for me. Circle for me the monomers. Remember, the monomers will be from break to break. Break to break. I put a different color. Green. So I do all this thing for you, man. You could do. Yeah. Wow. Yeah. Here. This is number 1. Number 2, diacid. Okay, so 2 there. So here, of course, will be what? Will be N. Just blue, red better. So it will be the N here. Put the N here. Okay, H. Obviously, it should be an amide here, okay, H here, right? And of course, this is your to bracket C. Just leave it alone. CH2 and 6 of them to N and H here and for the H here. Now this part here, this fellow here, okay. But the carbon now here can be a diacid or the acyl also, okay. After you see that, I didn't have time to teach the one now. I just go spread and do everything together. Now, okay, but OH here, they cannot put it wrong, or Cl here. Cl is better. Okay, I'll explain the next time I meet you. Okay, C6, C2, CH2, sorry. 4, this is your nylon 66, okay? Okay, and your CO here, and of course will be your the acid or your diacyl can. See now? See? Right? Same idea. Okay, now some more. B. Ah, voila, B, of course, you can see the main chain is all carbon, carbon, of course here to be carbon, 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 carbon. That means it must be a what? Addition, type of reaction, addition. Okay, the monomers, just take a start anyway. 2 carbons, 1, 2, circle. 1, 2, circle, they are the same. So it's polypropene, is it? No. Oh, the double bond must be here, is it? So 2 carbons here. So 1, 2 carbons here. This carbon, this carbon, this carbon 1, carbon 2, carbon 1, carbon 2. Down here is your, you put up here, now you want CH3 down here, and your H here, and the H here, and the H here, this propene. Yes, easy. Okay, now this one here. Is easier. Now this actually is a protein, by the way. Okay, now remember, if you got an N here, it means that it must be polyamide. So you put the C here. And double bond here. Alright. You can put out this here must be N here and H here. Since this is a repeat unit, it means that they must repeat. It means that there's only one monomer, not a copolymer. Okay? Which means to say that this is an amino acid. Right? This of course by what? Condensation. That's not. So remember now break the one here, break here, and break here. So what's the monomer? This whole thing. Okay. So N to H, it must be an amine. H here, 2 CH2 bracket 5, and must be carboxylic acid here or a acyl group. Up to you. Can be a Cl here. Okay. Okay, is that clear? All right. Now one more question. So much to cover. One more question. I just ask you to think over it as you ponder and reflect. Suppose say reflect. It's very important to think. Okay. All right. This thing is driving me crazy. Okay, page 353. Same idea. Okay. Same. Polymers, question 9, consists of monomers joined together by addition and condensation, blah, blah, blah. Put a tick. Okay, on the correct column, indicate the type reaction and with polymers give the monomer. Okay, say monomers. Okay, see the functional group here. Amine. Of course, is what? Condensation, is it not? Double bond here. Don't get this further here. Double bond here. Addition, is it? Right? Addition. Easy, is it? Yep. This is the one that I asked you just now. You know? Okay. Polyethylene bags pollute environment long term because they are non-biodegradable. Why? Remember I told you, right? They don't have the ester linkage, right? So they cannot undergo hydrolysis. Okay. Now look at this fella. Now this is very important. This is the new type. This polylactic acid. Lactic acid is formed in your body when you exercise. Not enough of oxygen. You know. This one here. Now this is the repeat unit. No. Okay. Right. One of the. Okay. This is a repeat. That means it can repeat itself. Now, if it now the point, look here, now look carefully. Now, what kind of linkage is this? Got carbon O. It means it must be a polyester, is it? It's not, right? It's polyester, and this end here cannot be a double bond. Now, that means both sides of them must have one of them will be alcohol group, one is a carboxylic group. It cannot be both sides carboxylic group. Think for what? I'll talk about it next day. That means this part here cannot, this part here, see now, this part here, right? Go here to CH3. Here cannot be a carbon with a double bond O. Cannot. Okay? Because you break here, this become a diacid. Yeah. Right? A diacid cannot polymerize itself. Right? Which means this part here must be this part here. Alright? This part here. Here CH3. Here must be O. Right? Join to a what? C. See now. So that means from here to here. And this must be your what? This must be your what? Your monomer, which means the monomer is what? It's like this. CH3 OH. Right? Two functional groups in one. The acid and the alcohol. See? Both ends also can polymerize. Go back and think about it, what I said. Try this on here. I will continue next day. Okay? Is everybody clear? Alright. Now I will probably have 3 or 2 more sessions. Right? Then I finish. You know, we finish A2 organic chemistry. Whole term's work. So up to you lah. You first, you want to study? Up to you. You want to study? Up to you. Okay. Now I'm going to how to do this. Every time I want to stop first. Okay. I don't want my face to come out here. Okay. Stop. Stop recording. Okay, guys. Goodbye.